This is the second video for the Unit 3 test review. We're starting on number 7. We're listing any asymptotes and holes. I like to first look for the vertical asymptotes. Remember that vertical asymptotes make the denominator 0, but not the numerator. So, and vertical lines are always x equals. So on letter A, -7 makes the denominator 0, but not the numerator. So that's my vertical asymptote. Then I'll look for, is there a horizontal or oblique asymptote? Remember, that's where I focus on the degrees of the numerator and the denominator. They both have the same degree, 2x to the first, x to the first on bottom. When they have the same degree, I take the ratio of the leading coefficients. So there's a 2 in front of the, the 2 is the leading coefficient of the numerator. There's a 1 on bottom. So 2 over 1 is 2. That means that I have a horizontal asymptote of y equals 2. Remember, when there's a horizontal, there can't be an oblique, so we're okay there. And there was no number that made the numerator and denominator 0, so there is no hole in the graph. On letter B, to figure out the vertical asymptote, or asymptotes, I'm going to have to factor the denominator. So again, you've done this many times. Use whatever method you're most comfortable with. But the denominator will factor into 2x minus 5, x plus 4. The numbers that make that 0 are 5/2 and -4. I should actually probably write that a little different. So x equals 5/2 and x equals -4. Neither one of those numbers, if you test, neither one of those make the numerator 0. So those are both good vertical asymptotes. That also tells me there's no hole in this graph. The degrees are again the same for the numerator. The highest degree is 2. The highest degree in the denominator is also 2. So again, I'm going to take the leading coefficients, the ratio. 1 on top for the leading coefficient. There's a 2 on bottom. So my horizontal asymptote is y equals 1/2. Again, there's no hole. And also, since there's a horizontal asymptote, there cannot be an oblique. For letter C, vertical asymptote, make the denominator 0, but not the numerator. So that is 3. This one, if I look at the degrees, the degree on top is 1 greater than the degree on bottom. That tells me this is going to have an oblique asymptote or a slant asymptote. So I know this one's going to have an oblique asymptote, which is basically going to be a diagonal line. The way I figure out the equation of that oblique asymptote, and actually I'm going to erase some stuff here so I've got room, is that I actually perform the division. So I'm going to synthetically divide by 3. Now be careful, my numerator has an x squared, but there's no x to the first. So I'm going to have to put in a 0 placeholder. Drop down the 1, multiply, add, multiply, add. Remember, though, that we actually are going to ignore the remainder for my oblique asymptote, so that doesn't really matter. So this left over is 1x plus 3. That's the equation of a diagonal line. So my oblique asymptote is y equals x plus 3. For number 8, we're back to looking at polynomial stuff. We're going to write a possible factored form for this function. So let's take a look at what my zeros are. -2 is a 0. 0 is a 0. And 1 is a 0. So since -2 is a 0, the factor is x minus -2, which would be x plus 2. Since 0 is a 0, the factor must be x. Now, you could write it here. I don't like putting it there. I prefer having the x out in front, so I like it there. But it doesn't really matter. And lastly, since 1 is a 0, x minus 1 must be a factor as well. Now, we still have more work to do here. Notice that at 0 and at 1, the graph bounced off the x-axis. That means it must have an even multiplicity. So I'm going to put a 2 on each one of those factors. That'll give it an even multiplicity. Now, the last step for this, notice that my graph is rising to the left and falling to the right for its end behavior. That only can happen if there's a negative out in front. So here's a possible factored form. I'm not sure if it's exactly correct because I don't know how low these things dip. I don't know how much of a wiggle there is there. But with the information given, I know that stuff at least has to be in there. On number 9, okay, we're going to go through all the different steps to build and learn about this polynomial. So part A just asks for the end behavior. Remember, I look to see that it's odd. That tells me it's going to go in opposite directions. And it's positive. That tells me that as far as end behavior goes, it's going to fall to the left and rise to the right. On letter B, the possible rational zeros. Remember, that is all the factors of the constant, technically -9, over all the factors of the leading coefficient, which is 1. So I don't really have to worry about that because they'll all be over 1. So remember, that means that it could be plus or minus. Basically, it's just going to be the factors of 9, which are 1, 3, 9. So my possible rational zeros technically are 1, 3, 9, -1, -3, -9. For part C, find the actual zeros, which will also be the x-intercepts. This is where you have to start doing a little guessing and checking. You're going to plug numbers in, or you're going to synthetically divide by these possibilities. Again, I'm looking at my possibles. And you're going to see what gives me a remainder of 0 or what equals 0. Again, those are synonymous. If you try the number 1, that's always a good place to start. I'd have 1 cubed, which is 1, plus 1 squared, which is 1, minus 9 times 1, which is -9, minus 9. That's definitely not going to equal 0. So that one's out. Let's say maybe I try -1. And again, what I'm doing is I'm plugging it in to the original function. So I'm actually going to write it out here so we can see what's happening. So this would give me -1 plus 1 plus 9 minus 9. And that does equal 0. So that was the keystone to this problem. I found out that -1 is a 0, and that's crucial. So I know -1 is a 0. More importantly, then, I can synthetically divide by -1, break this polynomial down. So if I put my coefficients, 1, 1, -9, and my constant, -9, I should be getting a remainder of 1. I'm sorry, remainder of 0. I think I said a remainder of -1. Sorry about that. I should be getting a remainder of 0, which I did. And this also condensed my problem down to x squared plus 0x minus 9. So to find my remaining zeros, I just have to figure out what makes this equal 0. You could either factor it, or you could add the 9 over in square root. If you factor it, you can see that 3 and -3 make it 0. On the next part, letter D, find the y-intercept. Remember, that's very easy on this problem. I just plug in 0 for x. So that would 0 out, 0, 0. All I'm left with is -9. So my y-intercept is 0, -9. And so now I can put all this information together and sketch a graph. So I know that I'm hitting at -1, 3, and -3. I know that my graph should start down below on the left and should end up high on the right. I also know that I'm hitting at 0, -9, so I'll just say here's -9. And each one of these zeros, or x-intercepts, only existed once. So they all have a multiplicity of 1, which tells me that I'm going to cross through. So I'm starting down low. I'm going to cross through the x-axis, hit your y-intercept, cross through. So there's a very rough graph, but it gives me the important information. I know where it's hitting the x-axis. I know where it's hitting the y-axis. I know that it's crossing through at each one of those x-intercepts. Okay, for the final problem, now we're looking at a rational function. First thing it wants is the y-intercept. Remember, I plug in 0 for x. So if I plug in 0 for x, this would just give me -3/4. So my y-intercept, 0, -3/4. For my x-intercept, I would be plugging in 0 for y, or 0 for the f of x part. So I'll just write this real quick. This would be 0 equals -3 over x plus 4. Well, remember, a fraction is 0 only if the numerator is 0. There's no way to make -3 equal 0, so there's none. There's no x-intercepts on this one. The next, it wants any vertical asymptotes. Remember, those make the denominator 0, but not the numerator. So that would be x equals -4. Horizontal asymptote. Well, now on this one, remember that my degree on top really on x's, let me rewrite this a little bigger. Really, the numerator can be thought of as -3x to the 0. The denominator has a degree of 1. The degree on top is smaller than the bottom. Remember, that means automatically my horizontal asymptote is y equals 0, which is really just the x-axis. So now I'm going to put some information together and get a graph of this rational function. So I know I have a vertical asymptote at x equals -4. There's my vertical asymptote. I know I have a horizontal asymptote at y equals 0, which again is just the x-axis. I know that I'm hitting at 0, -3/4. Let me get a few more hashes on here. So I do know that the graph is going to hit down about 3/4. Now, remember that you need to just pick a few other points on either side of the vertical asymptote to get a feel for what the graph's going to look like. So, for example, if I pick -6, and again, I'm just throwing numbers out there that are on either side of the vertical asymptote. If I plug in -6 into my function, that would give me -3 over -6 plus 4. That's going to be -3 over -2. So that's going to be positive 1.5. So at -6, I'm up 1.5. I'll try one more. If I plugged in a -5, that would give me -3 over -1, so 3. But -5, I'm up 3. Let's try some points on the other side of the vertical asymptote. So if I tried, let's say, -3. If I plug that in, that's going to give me -3 over -3 plus 4. So -3 over 1, which is going to give me -3. So -3, -3. And I'll try one more, -2. If I plug that in, that'll give me -3 over 2, so -1.5. And with the general feel that you've been seeing on what these rational graphs look like, the way they hug those asymptotes, this looks like I'm going to be up top on the left side, and on the right side, I'm going to be down below, hitting that y-intercept. So something like that. Okay, that does it for the paper review for the Unit 3 exam.